Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Comparative Analysis of PSO-based Waveguide Arrays with an overview of existing schemes and technologies for multi-beam combination. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. I'm Deepak. Today I'm here to present you one of the unique research topic, that is basically to automate the waveguide selection for beam combiner. So these beam combiners are used in many of the areas. So to automate the process, we have proposed the hybrid PSO GSA approach so that we can get the multi-beam combiner system. So before moving to the video, let's talk about that what we will cover into this video. In this video, initially we will talk about in which application areas this discrete beam combiner automation can be applied for the real world scenarios. Then we will see whatever the code we have designed, how to execute it, what are the software requirements for it, then what systems are currently available for discrete beam combiners, and what are the problems identified in them, and how our proposed methodology is handling those problems. Finally, the experimental outcomes and the findings will be reviewed and the brief will be given to it. So let's talk about the application areas. So these beam combiners are specifically designed for the telescope interferometry, where the farthest places or the planets can be seen by using the more than one telescopes. So if we are using more than one telescope, so obviously the laser beams those are using to get those visuals are multiple in count and are to be put on the waveguides. So waveguides are basically in number of counts. So we need to select the best waveguides. So when the configuration was smaller, then it is okay, else it is a challenge for the research. So for the telescopic interferometry, this is one of the application. Other than that, the laser combiners can be used in the lidar systems for the defense or the military operations or related applications. Other than that, for the laser show systems, this is one of the recent technology which is very much popular. Even in the biomedical applications, for the healthcare applications where biomedical imaging can be done, where the lasers are being used for it, there these systems can be very effective. So these are the unique areas of the research for the PhD or the industrial people, where they can automate the processes instead of doing it with the manual phases. So what we have done and how to run this code. So the code that we have designed will be there like this. You can see we will give you the folder name code, under which we do have these folders. These two folders are for basically the proposed algorithm designed for the lower configuration set of 2x2 waveguide, 3x3 array of the waveguide, and 4x4 array of waveguides. Secondly, we have done it for the higher order, higher dimensional one, where 8x8 and 9x9 array of the waveguides has been developed and analyzed. So these are the codes under which we need to run it. So you can go for, in order to run the 2x2, 3x3 or 4x4, you just need to go to the folder. Here is the folder. This is of 2x2, where the code is designed in the MATLAB. So the MATLAB software that I am using here is 2019A. You can use 2015, 17, 16, 18 or 19. But make sure they are of full version, not the trial one. So in order to run the code, you just need to select the folder, select the path, go to the MATLAB, paste it here and press enter. When you will press enter, you will see the whole files. Those were there in the folder here. Out of this, you need to run code 2x2 _18 file. This is basically for 2x2 waveguide model. So if I'm running this code, you can see the whole code has been designed, and at the end we were saving the results. So all these results has been saved for the different configuration. The paper that we were following for this will be discussed once I'm running this code. For running the code, you can see when I just open the file, it moved to the editor window, and here is the run command. So you just need to click on this green button to run the code. So when you will click on the run button, you just need to give the wavelength in micrometer. So here we are using for 3.1 micrometer. Press enter. You can see it will process the whole code, and the fitness will be evaluated, where the fitness is kept in the increased intensity. So the intensity achieved from it is like 0.82 means 82%. The visibility is 0.90 means 90%. At a phase angle of this, the minimum and the maximum 1 by SNR value has been achieved for this. This is at a wavelength of 3.1 micrometer. The base paper that we were following for it is like 3D beam combiner, exploring the potential of this interferometry. There they have designed the system for 3x3 and 4x4 waveguide. As I already telling you, the array of telescopes are there, and then they are their beams has been put on the waveguides. Those are number in count, like 3 by 3 they are total of the 9 waveguides. We need to select the best 3 waveguides through which the light can be passed, and on the screen we can see the patterns. Similarly for 4x4, you can see there are total number of 16 waveguides, and we need to select 3, as the 3 telescopes has been considered in this scenario. So they were doing this part through the mathematical and the manual procedure for selecting the waveguide. So in order to automate the process, what we have done, the main contributions of the research are like we have automated the process by introducing the concept of optimization algorithms. Secondly, we are proposing advanced variant of PSO by clubbing it with the gravitational search algorithm GSA. So a hybrid model of PSO and GSA has been implemented to get the best waveguide numbers out of the array given. Thirdly, we have done it not only for the smaller array of the waveguides like 2 by 2, 3 by 3 or 4 by 4, which are generally people are doing. We are also doing this for the higher order dimensions like 8 by 8 and 9 by 9, where out of 64 we need to select the best waveguides. So this is what we have done into the proposed scenario. So here when we have run the code, all these factors have been saved to the different factors. Here it is of 2 by 2. Then I'm also going to demonstrate you for 3 by 3 and 4 by 4. So we again, the procedure is same. You just need to copy this file and then go to the MATLAB, and then path is to be pasted here. It will move to that folder. Here the 3x3 PSO and GSA has been there. So when I'm running this, you can see when the for 3 by 3 it is nanometer, where it was 2 by 2, then we have using the micrometer. Here in this scenario it is nanometer, because the base paper that we are following, they are using the configuration of nanometer with varying the wavelength from here you can see. So they were varying the, they've given the details here for the different wavelength, like here it is nanometers, 633 nanometers, and they are doing it for 640 to 690. So we just need to give the configuration similar as per of the base paper. So for 2 by 2 it is in micrometer, that is varying from 3.1 to 3.6. For 3 cross 3, 4 by 4 cross 4, it is 640 to 690, in order to compare that. So if I am entering for 630 or 640, it will execute the results for it and will save it. So I'm just commenting the save commands here so that the results will not get changed. So when I press enter, it will start processing it, and the factors similar as of the previous, like intensity, visibility, phase, and minimum of 1 by SNR, maximum 1 SNR has been calculated for the different scenario. Then all these factors has been, all these scenarios has been used in order to compare the results and to analyze the results, basically that which scenario is best in comparison to the additional things. So further modifications are still possible into it. We can do this processing. So this is for PSO GSA 2 by 3 and 4 by 4. Let's see with the 8 by 8 and 9 by 9. So I just need to copy the path again, go to the MATLAB, paste it here, press enter, then open the code this. So when I'm running this code, it is quite similar, where initially we have given the factors related to the setup of interferometry, where the screen distance in is given, what is the reflectivity and refractivity index has been considered, what is the window width and the grid size, along with the total count, because it is of 8 by 8, you can see the count of the grids are 64. Then the beams information has been given, which is in different zones by Then the lambda, which is the wavelength in the nanometer, has been considered as per the theta per second of 0.4. After that, final calculations has been made and optimization algorithm is used with the PSO GSO, and all the parameters has been given by generating the initial population, and that this is the initial configuration that we were using. Even by varying the results can be varied. And finally, the parameters those we are evaluating in the fitness are specifically for the intensity. So intensity calculation has been done, and the maximum intensity combination of the waveguides is being used as the final outcome. So out of the total configuration set, we are counting the we are selecting the best waveguide combination in order to get the higher intensity, more visibility, and less variation in the signal to noise ratio, right? So further modifications are still possible. The latest optimization algorithms can be embedded, and the more parameter dependency can be made, and many other options can be there. And obviously it is a unique domain for the laser beam combiner designing, which automates the process. So for any of the industrial application or for the research purposes, you can contact us directly and can get the details. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends, synopsis preparation, crafting a clear and concise synopsis with well-defined objectives, coding assistance, providing expert help with writing and optimizing code in various tools and platforms, research paper writing, assisting in drafting and editing research papers to meet the highest academic standards, dissertation writing, offering complete support for your dissertation, ensuring consistency and quality, plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.